All right, today we're taking a trip, a long one. We're heading out to the very edge of our solar system, to a world of incredible extremes and deep, deep mystery. Our destination? The eighth and final planet from the Sun, the windy, wild, and beautiful world of Neptune.
So I want to start with just one number, 1,200 miles per hour. Let that sink in. That is the speed of the winds on Neptune. They are by far the fastest winds ever recorded anywhere in our entire solar system.
To put that into perspective for you, these winds are supersonic. They literally break the sound barrier. It's just an environment of constant, unbelievable violence. So the big question is, how? How does a planet so incredibly far from the Sun's energy get this wild?
And that is the central question we're going to unpack today. We're going to look at how we even found this place, what it's actually made of, and the one and only brief visit that showed us just how strange this world truly is.
You know, our story here doesn't start with someone peering through a telescope. Nope. It starts with a pen and paper. Because the way we discovered Neptune is completely unique in the history of astronomy.
So, back in the early 1800s, astronomers noticed something was off. Uranus just wasn't where their charts said it should be. It was wobbling a bit in its orbit. So two mathematicians, working completely independently, came up with a crazy idea. What if the gravity of another, unseen planet was pulling on it? They did the math, they crunched the numbers, and they pinpointed exactly where to look. And in 1846, astronomers aimed their telescopes right at that spot and boom! There it was, the first planet ever discovered purely by prediction.
And to really wrap your head around just how far out Neptune is, think about this. 1 year for us is 365 days. A single year on Neptune takes 165 Earth years. That means that since we discovered it back in 1846, it has only just completed its first full orbit in 2011.
Okay, so we found it with math, which is incredible. But what is it? What is this distant blue world actually made of? Well, the answer to that is the real key to understanding its wild side.
Neptune, along with its neighbor Uranus, is what we call an ice giant. Now that doesn't mean it's a giant, solid block of ice. That term really just refers to its composition, a thick, slushy, super hot soup of different kinds of ices swirling above a small rocky core.
And the ingredients for this planetary slushy are key. We're talking about a massive mantle made of super pressurized water, methane, and ammonia. It's definitely not the kind of ice you find in your freezer.
And one of those ingredients, methane, is actually responsible for the planet's absolutely stunning color. You see, methane gas high up in the atmosphere is really good at absorbing red light from the sun, but it reflects the blue light back out into space. And that is what gives Neptune its signature, deep, rich blue hue. And right here, this is the biggest clue we have to Neptune's wild weather. It's so far away that the sunlight is incredibly faint, and yet the planet actually gives off more than twice the energy it gets from the sun. It has its own internal heat engine, probably from gravity slowly contracting the planet, and it's that internal heat that churns its atmosphere and powers those supersonic winds.
But the mysteries don't stop with the planet itself. No, we have to talk about its largest moon, Triton, which is honestly one of the strangest objects in the entire solar system.
See, almost every single major moon in our solar system orbits in the same direction that its planet spins. It's just how things work. But not Triton. It orbits Neptune backwards in what's called a retrograde orbit. And that is a huge red flag that something is very, very different about this moon.
What this strongly suggests is that Triton didn't actually form alongside Neptune. It's an outsider. That backwards orbit, plus the fact that it actively shoots icy geysers into space, points to a totally different origin story. It was probably a rogue object, kind of like Pluto, that wandered in from the Kuiper Belt and got trapped by Neptune's gravity a long, long time ago. It's a hint at just how chaotic the early solar system really was. So all of this stuff we know, the winds, the storms, the strange rogue moon, it's pretty incredible. But what's even crazier is that almost all of it comes from one single fleeting encounter.
That's right, in the entire history of space exploration, only a single probe, Voyager 2, has ever flown past Neptune. It was a brief flyby way back in 1989, but the data it sent back completely changed our understanding of the ice giants forever.
It's just amazing how much we learned in that short window of time.
Voyager 2 is what confirmed the supersonic winds. It discovered that massive Earth-sized storm called the Great Dark Spot. It revealed Neptune's faint rings, and it gave us our first incredible close-up look at Triton's icy volcanoes. It basically wrote the book on Neptune in just a few days.
And this really brings us to our final thought. That one flyby answered so many questions, but it opened up so many more. What happened to the Great Dark Spot, which has since disappeared? What's really driving that internal heat engine? After just one single visit, you have to wonder, what other secrets is this wild, windy world at the very edge of our solar system still hiding from us?